Hello guys, welcome to Code Climbers. In the previous video, we have seen how to create a singleton Java class. Now, I also mentioned that there are some issues with the implementation, and in this video, we'll see what they are and how to solve them. So here, if you see, we are instantiating the instance object as soon as the class is loaded. So assume the application has about 20 to 30 dependencies. If all of them instantiate the objects uh, right when application is loaded. This will create performance overhead as well as memory overhead. So to avoid that, we need to lazily initialize the objects. By lazily initializing, I mean that we need to initialize for the first time just before when the object is accessed. So for that, we can modify the code as follows. First, let's remove the assignment of the instance object, and we need to assign the object only if instance is null here. Instance is equal to new payment gateway. So yeah, here you can see that we are instantiating the instance object only if instance is null. Now, this works well in single-threaded environment, but most Java applications are multi-threaded and there will be uh, multi-threading issues here if you look closely. For example, if two threads try to access the getInstance method, the first method might go inside the if block and create the object. At the same time, the second thread also might go inside the if block and create the object. So this will result in two separate objects, which defeats the purpose of singleton class. So to avoid that, we need to uh, add synchronized keywords in proper places to mitigate this. So one simple way would be to add synchronized keyword to the method itself. This will make the getInstance method synchronize, but this is an overkill because we need to synchronize only when instance is null. We don't have to synchronize the method when instance is not null. We can just return the object to any number of threads. So further, we need to move synchronized object inside the if block. First, let's create a lock for the synchronized keyword. So it would be a static final lock. Okay. Now, if we specify the synchronized keyword and then move the instantiation inside the synchronized keyword. Now we can see that the synchronization optimization is done, but there still are some issues with this. Firstly, when we access instance object, it might create data race conditions when multiple threads are accessed. So to avoid that, we add volatile keyword. Now, this is good for most cases, but there is one more optimization that we can do here. That is uh, one more point. So, between the synchronization of the entire getInstance method and moving it inside F block, this will result in almost 100 times improvement in performance. Okay. Now getting back to the final optimization. Uh, if you see here, we are accessing the volatile variable two times here. Uh, one first to check if it is null and then finally to return. We can reduce this number to 1 by having a temporary variable. So we assign it to instance and then we use this temporary variable for all the checks. Okay. Now, okay, we need to return temp. Okay. I forgot to mention there is one more issue here. So when two threads are trying to access the synchronized block inside if statement, first thread might have already acquired the lock and initialized the object, but the second thread, when it tries to initialize the object, the both of them might initialize the same object twice. So to avoid that, we need to add one more null check here inside the synchronized block. Before this, we should also assign temp with instance. Okay. Now, yeah, this is the final singleton class that is completely thread safe and you can use it. You can use this logic everywhere. In fact, uh, all the lazy initializations that happen in Kotlin or similar language, JVM language, they use this same logic. So yeah, there is one more simple way that we can implement this singleton class in a thread safe manner that we'll discuss in the next video. So please continue on the next video and thanks for watching. Please do subscribe.